So, we will again run on Colab, okay, these all run on Colab, but instead of C I use C++, okay. But this code will also run on C compiler, but C++ I prefer it because our main code was object oriented. So, C++ in fact IO is much better, okay. I do not like the scanf, and a lot of you probably know that is something which I really hate, the scanf and printf, formatting and the pointer. So, C++ is clean for those operations. Okay, so we just use C++. So, this interface is very similar to Python, but well, we need to do some more, which I am going to do it. Well, let me just say it right now. So, I did check or compare the performance with Blitz and without Blitz, with the new compiler, new hardware. We used to use Blitz in the past, but it turns out C is doing better with native arrays, at least in this example. So, I want you guys to do some more test. Okay. So, the numbers are very revealing. Okay. So, in fact, our codes we should just abandon Blitz, it appears. Okay. So, anyway, so there is we wanted to put in Blitz. So, there is a way to put Blitz. So, I will share that notebook, Google Colab notebook, and you will see how to run this install in your machine. Okay. Some of it you can ask the TA for help. Okay. He will help you to install. You need some libraries, then you need to install. Basic C++, you do not need to install anything. Okay. But I thought I will test with Blitz. Okay. Now, let us go straight ahead and look at numbers. So, by the way, it is also a good idea to know how to install GCC on your laptop. Okay. So, in Mac it is very standard, just one line, that is it. Okay. So, brew install GCC. So, this brew is like brew is a repository. Okay. So, brew is a package which will you can see that if you install some library, then it requires compilation, then build. I do not know if you have done some compiling. Let us go back. Here you can see that I got the package from JIT. So, this is a repository called GitHub. Okay. You should know about GitHub. I did tell you about GitHub very briefly. That is where lot of codes are there. Okay. So, GitHub I have downloaded it, then it is there in Blitz directory. Okay. Then basically start from here, CMake. So, this is what is basically compiling it. So, CMake, you remember I was using a package called CMake, well, not using it, I was recommending that you use CMake for compilation. So, the CMake will compile based on all the dependencies. Okay. So, it will take care of the bottommost code, then other files which require import.h in C you might know. So, that sequencing is very critical, something which does not require any dependence should go first, then next layer. So, CMake does it. So, it has a CMake file, and then make lib and make install. So, it makes a library and is stored in library. Okay. So, it is there in our Blitz. Well, I did, my TA helped me, Manthan helped me. So, it is there installed in my Google directory, hard drive, Google Drive. So, if you are wanting to install in your own laptop, then you need to do this on your laptop. So, you do to download, then you do CMake, then make lib and make install. And in your lib directory, you need to have a place where it will install. So, I need to go to the Blitz, well, particular place where you want to install your library. So, it is a setting up a library. And this some of it you can also learn in Google, just do some search and how to install a package in Linux or Mac. Okay. So, for Mac, brew takes care of all that build, CMake build, all that will do it. Or in Windows, what you do is double click, right? This is a package .exe, you double click and it installs. So, in Mac we do it by brew. Some of it also comes with double click. So, called DMG file, you double click and install. okay. But GCC does not come with double click typically, there are some double click things, but it doesn't come. And this will give you version, which version of GCC. So, you should install the latest version. Okay. You need to do version which is OpenMP. Okay. OpenMP compatibility. OpenMP will need for the class. Now, Ubuntu, so this is called APT. So, there was a brew in Mac, APT is for Linux. By the way, so yeah, so this is the one I showed you was from scratch. You are doing yourself, but APT is a package. APT is basically an assistant who can help you install by just one line. Well, you need to okay, this is a copy, is it? Yeah, this is just a copy. So, just one line. First update it so that it has the latest package, information about latest package, where it, well, it does not bring all those files, but it knows, it will update it so that it will bring the latest package from GitHub, or it is very clever, it knows where to get this stuff from, and it will do it. Okay. But I will not spend too much time on that stuff. Okay. So, timing using C++, I use Chrono library. So, Chrono is a good library which gives you in milliseconds or microseconds, sorry, it gives you in microseconds. So, we will just use this start and stop variables which will time it. So, I use T1 and T2 in my Python code. So, T1 was start and T2 is stop. So, we will just use Chrono here. Okay. So, duration will be the difference between start and stop, and I divide, okay, that has been cut 1 E3. So, this is in microsecond, I do not want microsecond, I want only millisecond. So, I just divide with 1000. Okay. And C out, this is for output, no, I mean if you know in C it would be quite clumsy with the printf. Okay. Now, compiler has, okay, so this is where I am coming. For Python you do not need to do a compilation, there basically you run Python file name, right, or in Colab you just there is a arrow and you click. So, you do not even need to do Python file name, it just works in Colab. But in C++ you have a C++ file, you need to compile it, and I discussed about compilation in the past. So, it will convert it to, well, it does not, it converts it to object code, and that you have to also build it. So, it has to be put in the RAM. So, there is something called operation called build. Okay. So, but compiler will do both. Modern compilers, we do not want to do 2 steps, it will just make a executable file. So, generates a executable file, but compilers come with many options. Okay. For GCC the options are -O1, -O2, -O3. O is O for object, is not a number 0. Okay. Option 1, option 2, option 3. Okay. Option 3 is the fastest, but for large code it will take time. It may take several minutes for large code. For simple codes it does not take too much time. Okay. But O3 is definitely takes longer. It will be in milliseconds, but one will take 100 milliseconds, other one will take 3 milliseconds. Okay. So, we are going to use all 3 and see which is faster and by how much. So, you should, I recommend that you should do -O3 option or -O first option, and we find that both are similar. Okay. If you look at the compiler options, there are 100 options, well probably more than 100 options. Okay. But I do not know much about all the other options. OpenMP also will be an option, okay. But for optimization for a sequential code, I did not do any parallelization, I have sequential code that I want to run fast. Okay. So, we will use these options and check. Okay. So, we have got back to our old code. With O3 it will be much faster. So, just look, we will wait for the numbers. Okay. I am going to show you the numbers. So, we do exactly same operation, matrix element by element multiplication, array multiplication. So, it is shown by array multiplication. Okay. So, this is the thing AI star BI. So, without any option it was 675 milliseconds, okay, 0.6 seconds, okay, uncertainty 10%. Now, let us use options. With O1 it is 79 millisecond, which is already 10 times faster, O1 itself. With O2 it is 0, well it is not 0, it is in microseconds. Okay. Now, I did not want to, so one thing is to put another loop here, so another loop here, or use a bigger array. Okay. But look, I mean this is O2 and O3 are giving 0, that means this is extremely fast, O3. So, these are all very efficient made, I mean their compilers knows how to make this code very efficient, this multiplication. Modern compilers, I mean these compilers which I used 10 years back, they were not so good, but now they are very good, and hardware also has become faster with more resources, vectorized operations and more registers. Okay. So, clearly you should use O3, right, I mean that is what is the message from here. O fast is also 0, but I am not compared, well now I need to put a turn on the microsecond thing, but microsecond is not a good thing to test, there are always fluctuations. So, definitely do not rely on 4000 microsecond is better than 3500 microsecond, that is not a good measure. Okay. So, 1D. Now, we can do this for 2D array without any option is 1.49, it is doing ij, okay, the ij loop, and with O3 it is 0. So, well I mean there is some time, but it is very small. So, keep this number in mind, 1.49. Now, with GI loop it is 12.4. So, I will give you the code and you can check yourself, I mean your numbers will be maybe 11 or 13, but it will be around that number. So, how many times? Around 10 times slower with the GI, or 8 times slower. O3 is 0. So, O3 was clever and it said that, well, it should be ij not ji. So, gi loop was flipped to ij and to get 0. Okay. Now, I told you there is a library called Blitz which we used in the past. In fact, for C++ code we still have it, we use it sometimes, but not very much now. So, we use Blitz because vectorized operations were not very fast in for the original arrays of C. Okay. So, C by the C arrays are accessed like that. So, be careful, I mean ij is written like this, 2 brackets, and there are reasons for it. So, I will not get into that. So, this array operations were very slow in before 2010. So, the decision maker was, well I took the decision that we should use some fast libraries for array operations, and Blitz was one of the very good ones. So, it uses something called template metaprogramming. Okay. Now, I do not have time for it. So, this is called lazy evaluation, template metaprogramming. So, these are ways to speed up your operations. In fact, they used even this very general thing for speeding up some long operation, how you should sequence them or when you should evaluate them. Okay. So, this part we will not get to it, but there is a paper by the original by the creator of Blitz which has some details on these issues. Okay. So, let us look at Blitz. So, Blitz allows this kind of C equal A star B operation, but okay, C++ the current C++ without any package does not allow C equal A star B, but now C offers something called vector. Okay. So, there is a vector package, you can call it, okay, module, and with vector you can write this kind of stuff. Okay. For running on GPUs, we need to convert it to this vector operations which are optimized with for GPU. Okay. I am not using vector right now, I will just use loops. For I used only loops, I did not use vector for C++, but array Blitz allows uses of vectors. Okay. This is like MATLAB syntax, no, or Python syntax. Okay. So, the Blitz syntax is like this. Okay. Blitz array declarations are like that, a bracket n. So, it looks like Python notation, and we initialize by random, but the random number of blitz is better than C, standard C. Okay, so that could be another way, other reason why blitz is slower for this function. Blitz is slower right now. So with option without any option 2.69, I have a table which will compare all of it in a soon. O3 option is 0.52. This one is in fact without any option this is worse. This one is worse, which is surprising. I do not believe it, but it is what that is what I got. At O3 option is 0.24, which is better, but I think but the blitz another problem is it is not under development. So, that is a big problem. You need to be at package. If you do not optimize it for the new hardware, that is not going to have any life. So, 2D arrays numbers are again not good. GI is definitely slower 10 times, but with optimization is getting faster, and here 5.49 and 0.22. Okay. This number is getting worse for some reason, okay, A star B. So, this multiplication is not working well. So, let us look at the summary. So, remember 1D array is 10 power 8 numbers and 2D is 10 power 4 by 10 power 4. 1D loop, so look at 1D loop. Python is 48 with loop okay, 48 seconds. C++ 0.675 seconds, O3 operation is 0. So, if you are using O3 then C++ is doing very good, okay. And blitz with O3 option is here, which is doing worse than C++, okay. It is a surprise for me, but that is what it is. 1D vector is quite fast 0.35, which is comparable to blitz, okay. Unfortunately, we can't do vector operation in C++ without vector package, okay. 2D loop with O3 it is 0, but Python takes around 1.16 seconds, okay. And blitz is not doing good, I mean 0.213. So, GI is slower, GI is definitely slower in C++. So, GI you should not do, but if you optimize it, you use O3 option. The major summary is if you are using C++, use O3 operation, and is basically very small, and 2D vector is 0.38 and here and is 0.223 here. So, well, some lessons to learn is use O3 option for C++. Python is very fast and is comparing with blitz, and blitz does not have a feature because it is not under development. Unless somebody kind of rewrite blitz, we have to abandon it. Okay, so I will stop here.